Assalamualaikum and selamat sejahtera. This topic is an introduction to power electronic converters and their main components, which are semiconductor devices. As an electrical engineer student, you should know that all electrical appliances can be categorized according to their power requirement. There are AC and DC power appliances, or commonly known as AC and DC loads. Based on the following photos, can you identify the category of these appliances? Since power supplied from the electrical power grid is AC, hence, all DC appliances have a converter to convert the grid power before the apparatus can be functional. This converter utilizes electronic components which are semiconductor devices to perform power conversion. For this condition, the converter needs to convert AC power to DC power, and the converter is called a rectifier. Ideally, the rectifier converts sinusoidal AC voltage to constant DC voltage. Unlike low power electronic circuits, this converter usually is operating at the grid power level and frequency. There are single-phase and three-phase converters connected to the single-phase and three-phase power systems, respectively. Due to the high power handling, the semiconductor devices are called semiconductor power devices or power switches. Moreover, owing to the usage of the power switches, the converter is known as power electronic converter. Other than the power grid, we can use DC power sources such as solar panels, wind turbines, or batteries to supply power to the DC appliances. However, the power provided by the DC sources may higher or lower than the appliance's power requirement. Therefore, these appliances still require a power electronic converter to step down or step up the input DC power. The converter that performs DC to DC power conversion for DC regulation is known as a DC-DC chopper. Meanwhile, we can also use the DC sources to supply power to AC appliances by using a DC to AC converter. The converter is called an inverter. Lastly, there is an AC to AC converter that is used to change the amplitude or frequency of AC voltage or current according to the load demand. The amplitude can be regulated using an AC voltage controller, while the frequency can be controlled using a cycloconverter. In general, power electronic converters can convert electrical power from one form to another form using semiconductor power devices. To perform power conversion, the power switches are connected in a specific configuration to change the current direction or to control the current flow from the source to the load. Depending on the types of power switches, the power conversion can be either uncontrollable or controllable. In regulating the operation of the converters, we need a control signal. Normally, a control circuit generates the signal by comparing the output signal of the converter and its reference signal. To amplify the control signal generated by the control circuit to a level required to drive a power switch, we need a drive circuit. Hence, this circuit will act as an interface between the control circuit and the power switch. It also provides electrical isolation between the control circuit and the power switch for protection purpose.